Hello everyone. In today's class, we are going to continue with question number 11 from exercise 15.1. Suppose three bulbs are selected at random from a lot. Each bulb is tested and classified as defective D or non-defective N. Write the sample space for this experiment. First, I will start by writing the general formula for sample space. The general formula for sample space is given by A power n, where A is going to be number of possible outcomes and n is going to be number of times the experiment is performed. Here, suppose three bulbs are selected at random from a lot. Each bulb is tested and classified as defective or non-defective, right? So either the bulb can be defective or non-defective. So the possible outcomes are D or N, right? So two possible outcomes are there. So sample space for this question is going to be 2 raised to the power. How many bulbs are selected? Three bulbs are selected at a random. Three times the bulbs are selected. 2 raised to the power 3. The answer is going to be 8. This is going to be the sample space. Now, if I have to write it in detail, how can I write it? I can write the sample space as you are selecting three bulbs. So all the three bulbs can be defective, or all the three bulbs can be non-defective, or the first two bulbs can be defective, the last one non-defective. Similarly, non-defective with defective, right? Next, you can have defective, non-defective and defective, non-defective, defective with non-defective. Next, you can have defective with defective and non-defective, non-defective, defective and non-defective. This is taken out. So NND, that is what NND is done, right? DDN is also done. Next, what I have to take? NNDDN. Okay, NND. Yes. So I will be writing NND. These are the possible outcomes: 1, 2, 3, 4, 5, 6, 7, and 8. Total possible outcomes is going to be 8. So the sample space for this experiment is 8. Question number 12. A coin is tossed. If the outcome is a head, a die is thrown. If the die shows up an even number, the die is thrown again. What is the sample space for this experiment? I will start by writing a coin because we have a coin and we have a die. Total possible outcomes for a coin is going to be 2. Either you can get a head or you can get a tail. For the dice, it is going to be 6. 1, 2, 3, 4, 5, and 6. These are going to be the possible outcomes. So 6. I will be writing case 1 and case 2. Case 1 and case 2. In case 1, if the outcome is head, if the outcome is head, then the corresponding number on the die is an odd number, right? Can I tell that? So if outcome is a head, then the die is thrown. If the die shows up an even number, then the die is thrown again. Again, it is thrown. So with a head, if I get a head, so I will start writing head. If I get a head, then again the die is rolled, right? So I should be taking all the odd numbers. H with 1, similarly H with 3, H with 5. So three possible outcomes over here. These are the three possible outcomes. So this is when the sample space, when you get a head and then a odd number. Next, when the outcome is a head and the corresponding die shows an even number. So first you are getting a head, then you will be getting a even number. If that is the case, again the die is thrown. So for that, it is going to be equal to totally how many we have? We have six. We have three over here, right? We have three over here, and with heads we can take all the numbers. So h with 2, because the first even number is going to be 2. Then again, if it is rolled, either you can get a 1, then h with 2, and then if you roll the die again, you can get a 2, right? Similarly, h with 2 and 6, sorry, 3. Similarly, h with 2 and 4, h with 2 and 5, h with 2 and 6. What it means is, this is the second case. The first case is this one. So let me mark over here. If the outcome is a head, so a coin is tossed. If the outcome is a head, then a die is thrown. So if you are getting a head, then a die is thrown, right? So you are throwing a die. If the die shows up an even number, then again the die is thrown. What it means, if it shows an odd number, you are going to stop there. So if you are getting a head first and then you get an odd number, you are going to stop. Either you can get 1, or you can get 3, or you can get 5. So possible outcomes here is going to be 3. For the case number 2, let me write this as case 2. Case 2 is this one. So you are throwing a die and you are tossing a coin first and then you are getting a head. And then you are throwing a die and you are getting an even number. If you get an even number, then again once you will be throwing a die. So you can get a head and you can get an even number, which is 2, and then 1, 2, 3, 4, 5, 6. Any of these 6 numbers you can get. Similarly, you can get a head, you can get a 4, and any of these two, all these 6 numbers you can get. So basically, here we are going to have 6 possible outcomes. For 4 also 6 possible outcomes, h comma 6 comma all the numbers. For this also 6 possible outcomes. So totally I can write this as 3 plus 6 plus 6 plus 6. 3 plus 6 plus 6 plus 6. Okay, so this is going to be h with h. Okay, have I missed something? 1 1. Okay, h with h, and 1 2 3. Okay, and h with h. Okay, fine. H and h, how much will we be getting? Sorry, wait one second. Instead of doing this way, it will, you can take, instead of adding, because you have to write everything, right? If you have to add, instead of doing this, you can write it this way. Since both are dependent events, I can use my multiplication over here. To use the multiplication, I will be writing here, I have 3 as the sample space. So total sample space is going to be equal to 3 multiplied by, here what is the total number I can have, what are the total possible outcomes. So I can get a head, right? Then I can get any of the even number, I can get. So either I can get 2 or 4 or 6, any of this if I get, then I can go to the next step. What is the next step? Next step is going to be, I can throw a die. When I can throw a die? Only if I get a even number, only if I get a even number. So once I get an even number, I can throw a die. For die, how many chances are there? Six chances are there. So basically, you can get a head. Any one of this number you can get, and any one of this number also you can get. So totally, the sample space for this is going to be, since these are also independent, these are also independent. What I can tell totally, what is going to be the sample space for the second one? Can I write it is going to be 1 over here and 3 over here and 6 over here. So I can write multiplied by 6, 1 anyway, multiply or not, it does not matter. So it is going to be 18 for this case. You can write this as 18. We'll be going to the next question, which is question number 13. The number 1, 2, 3, and 4 are written separately on 4 slips of paper. The slips are put in a box and mixed thoroughly. A person draws 2 slips from a box, one after the other, without replacement. Describe the sample space. So they have given the bills are numbered 1, 2, 3, and 4. These are the bills. Next, when two slips are drawn without replacement, two slips are drawn and it is going to be without replacement. What is going to be the total sample space? That is going to be the question. Now, for the first slip, how many slips can you draw? Either you can draw first one, second one, third one, or the fourth one. So basically, you have four possible outcomes. Four possible outcomes for case one. Or I can tell for the first slip, four possible outcomes. So whenever you are picking the first slip from the box, you have four options to pick from. Any one you can pick. So this is going to be the first try. In your second try, how many can you pick? One of them is already picked on the first try. So how many options are left? Now you have only three possible outcomes that you can get. Only three possible outcomes you can get because one of the slip is already removed. Right? Now the total sample space is going to be, since the two are dependent. Since the two are dependent, I can write sample space is going to be 3 multiplied by 4 or 4 multiplied by 3. It is going to be 12. What are these sample spaces? Even that I am going to be mentioning. So you can get the first number on the first try. On the second try, you can get 2. Or first try you can get 1 and second try you can get 3. First try you can get 1 and second try you can get 4. Or on the first try you can get the 2, second try 1, 2 with 3 and 2 with 4. Similarly, you can get 3 on the first try and then you can get the number 1, 3 on the first try, then you can get number 2, 3 on the first try and second try you can get 4. Or you can get 4 on the first try and 1 on the second try, 4 on the first try and 3 on the second try, 4 on the first try and 2 on the second try. So total sample space is going to be 12. What are the sample spaces? These are going to be the sample spaces. These are the possible outcomes. Question number 14. An experiment consists of rolling a die, then tossing a coin once if the number on the die is even. If the number of the die, if the number on the die is odd, the coin is tossed twice. Write the sample space for this experiment. This is our question. First, I will be writing a coin and a die. The question is about a coin and a dice. Okay. Coin and a dice is written. The sample space for the coin. What are the possible outcomes for a coin? Either you can get a head or you can get a tail. For dice, either you can get one, two, three, four, five, six. So here two possible outcomes. Here six possible outcomes. This is the first thing I'll be making a note of. Now, this experiment can be divided into two parts. Why? Because here it says that an experiment consists of rolling a die, then tossing a coin. So it is rolling a die, then tossing a coin once if the number on the die is even. If the number on the die is even, then the coin is tossed one time. If the number on the die is odd, then the coin is tossed two times. This is the condition, right? First, I will be writing case 1 and case 2. Case 1. I will be starting with case. First, when you roll the die, when you roll the die, you will be getting a even number. Assume that you will be getting a even number. Okay. So I will be writing this as sample space of getting a even number first. What is this going to be? Okay. If even number I have to get 2 or 4 or 6. So if I get a 2, if I get an even number, then a coin is tossed. So if a coin is tossed, either I can get a head or a tail. So with 2 I can get a head, or with 2 I can get a tail, right? Similarly, I can get 4, which is an even number, and then once the coin is tossed, I can get a head, or I can get 4, which is an even number. Then when I toss a coin one time, I will be getting the tail again. Similarly, I can write with 6 also, because 6 is also the even number. So here the total sample space I have got as 6. Total sample space, it is going to be 6. Okay. Now these are not dependent. Why? Because if I get an even number only, then the coin is tossed one time. But if I get an odd number, then what will happen? The coin is tossed two times, or coin is tossed twice, right? So that is going to be case number 2. Case 2. In case 2, whenever you are rolling the die and you will be getting an odd number. So what are the possibilities that you can get an odd number? Either you can get a 1, 3 or 5, right? So I will be writing SO, sample space of getting the odd number on rolling the die. So when I roll a die and if I get a 1, then it is an odd number, right? Then what is going to happen? Then the coin is tossed two times or twice. So I know that sample space of a coin when it is tossed two times is going to be HH, TT, TH and HT. So the same thing I can mention over here. H, comma H. Or I can get 1, which is an odd number. Then again, when I toss the coin two times, it can be HT or 1 H and sorry, T and T, 1 T and H. So these are four possible outcomes when I get 1, which is an odd number. But you can get 3 also, because 3 is also an odd number. So the same thing you have to be mentioning. The only difference is you will be starting out with 3 and also 5. And also 5. Totally here you are going to have 12 possible outcomes. Sample space of rolling a die and then getting a odd number is 12. Sample space of rolling the die and getting an even number is 6. Total sample space ST is going to be SO plus SE, which is going to be 12 plus 6. It is going to be 18. This will be your final answer. This is going to be your final answer. Next question is 15th one. A coin is tossed. If it shows a head, we draw a ball from the box which contains two red balls and three black balls. If it shows head, we throw a die. Find the sample space for this particular experiment. I will start by writing a coin. Then I will be writing a ball. A ball is there. Next, a coin is taken already. Then a dice is also there. So dice I will be taking. Let me write the sample space of all of them. H and T, two possible outcomes. Whenever you are throwing a ball, what is the possible outcomes? There are two red balls and three black balls. So I will be writing R R B B B. R R B B B. These are the possible outcomes. So 5 is the sample space. For the dice, it is going to be 1, 2, 3, 4, 5, and 6. Again, I will be dividing into case 1 and case 2. Case 1 is going to be when you toss a coin and you get a tail. So when you toss a coin and you get a tail, case 2 is going to be when you toss a coin and you get a head. Okay. First, if a coin is tossed and then a head is shown, we draw a ball from the box. Okay. So I will start by writing ST, which is the sample space, whenever the coin is tossed and I'm getting a tail. So whenever I get a tail, I can choose one ball from the box. One ball from the box. So what are the balls that I can choose? So when I get a tail, either I can choose red ball. I will be writing R1, R2, B1, B2, B3 just to differentiate between the same. Okay. Because they have not given it is identical. They have not given it is identical. So I can get a tail, then I can pick the red ball, the first red ball. I can get a tail, I can pick the second red ball. Similarly, tail I can pick the first black ball. I can get a tail, I can pick the second black ball, tail, and a third black ball. Total sample space here is going to be 5. Next, whenever the coin is tossed and we get a head, then what happens? Then we throw a die. Then we throw a die. Right. Now, sample space when a coin is tossed and we get a head. So whenever we get a head, then what we are doing? Then we are throwing a die. When you throw a die, either you can get a 1, right? With head, you can get 2. Again, with head, you can get 3. With head, you can get 4. With head, you can get 5. With head, you can get 6. The total possible outcomes is going to be 6 over here. It is going to be 6 over here. ST, which is the total sample space, is going to be the sample space of case 1 and case 2. That is sample space when the coin is tossed and you get a odd number. Sorry, you get a tail. Okay, this might be a little confusing because I will be writing ST for the tail, right? So I will be writing here S total just to prevent the confusion. Sample space when you throw the die and when you toss a coin and you get a tail, and when you toss a coin and when you get a head. So here we have got this as 5 plus 6. Total sample space is going to be 11. Total sample space is going to be 11. This is your question number 15.